So good morning, everyone. So the next session is talking about machine learning. So we have a speaker, Conan. So he's a specialist in machine learning and data mining algorithm. So let's welcome Conan for the presentation. Thank you.
All right. So I'm Colin. I'm a data alchemist at Slice Technologies. Slice Technologies is a subsidiary of Rakuten. So as a data alchemist, my team is responsible for taking unstructured data, dirty data, messy data, and turning it into gold, making it actually useful for insights. So part of what we do is build machine learning engines to make data structured. So very brief introduction to machine learning. The idea is we want to build computer systems that can learn from training data and make predictions from new unlabeled data. So a quick example is email spam classification. You build a training set where you say, here are the emails that are spam, here are the emails that are not spam. The machine takes this training set, learns the correlation, and then for a new email, it will say, this email is spam or this email is not spam. So we're at an interesting age where we have a high level of advances in data science, machine learning, AI, but we've also become a more interconnected world where very quickly we can access a lot of different humans all over the world, a crowd of people, and ask them questions, whether it be in Google search, where billions of people are using the product every day, or Facebook, or there's crowdsourcing technologies like Mechanical Turk. You can ask people to do tasks for you. So the question is, who do you trust more? Do you trust a machine learning engine, an AI bot that has no human involved to do the problem? Or do you trust thousands of people or millions of people to do the problem for you? And I guess it's an interesting question, but maybe we don't have to choose one or the other. Maybe we can get both. Can humans and machines work together to build a better system? Because if you think about it, machines are very good at processing lots and lots of data, but humans can some tasks machines cannot do very easily. They can do it very well. Humans, especially when we leverage many humans working together to solve a problem. So before I get into how we're doing this Slice, let me just give a couple of context about what Slice is. So Slice was founded in 2010. We have 3 million online shoppers, and for each of the online shoppers, we have access to all the consumer purchasing patterns they made across the several years. So each shopper, we know they purchased an iPhone from Walmart, these shoes from Nordstrom, at this price, at this time, and so on. And the data set to build this are e-receipts. So each of these online shoppers link their email accounts. After linking their email accounts, we extract data from e-receipts. So the way people link their email account is by joining one of our mobile apps that give them value. We have 2 mobile apps today. One is Slice, which is for online shoppers. The other one is called Unroll, which is for users to quickly unsubscribe from emails. So after users decide to link email accounts with one of our 2 mobile apps, then what we do is we have an engine that first goes through the email accounts, tries to find the receipts. What is an email from Amazon? Is that a receipt or not? For each receipt in an email account, then it tries to extract the fields. What was purchased? What price was it purchased at? When was it purchased? And so on. And then we do data science to make this a meaningful, structured data set to then use for insights. So in e-receipts, we have a lot of different type of data. We have receipts from e-commerce sites. We have receipts from offline retailers. We have receipts for concert tickets and travel reservations, hotels, and so on. So just a lot of variety in our data set about what we extract from each online shopper. And so with this variety, it's very, very important to structure the data set accordingly. So we can take a product that was purchased in the receipt. This is just raw text. But having raw text is not very useful. We need to basically categorize each product. In this first case, we can say that this user has bought a camera lens. We can say the second user has bought a mobile phone. Rather than just dealing with unstructured text, can we actually categorize for these products were purchased? And we have about 1,300 different categories at Slice, and a 5-level hierarchical taxonomy. So basically, we have level 1, in this case, electronics and accessories, level 2, cameras and photos, and then level 3, camera lens. So our basic problem is we need to categorize text data into a set of 1,300 categories. And so the traditional approach to machine learning for categorization is you build an engine, and this engine is built from training data, and it's built from a learning algorithm, basically a machine learning algorithm that take the training data and generalize. So you have a machine learning engineer, creates a training data, creates an algorithm, and then for this engine built, you then apply new data and categorize it accordingly. The problem with the approach is that it doesn't allow for evolution. So let's say that you build a machine learning engine today, you get 90% accuracy today. 1 year from now, it may not be 90% accurate. Why? This might be because we have new products. For example, Apple Watch just came out, and if you built your training data 1 or 2 years ago, Apple Watch may be categorized as a phone rather than as a smartwatch. So new products that are coming out every day. So it's very important that the machine evolves as products evolve accordingly. So you can't just have a machine learning engineer build a machine, say, I'm done. Here you go, here's the solution, see you in 10 years. That doesn't work. You need to have a system better and better and better. And additionally, there's a long tail of edge cases. So to get to 80% accuracy is pretty easy. To get 90% accuracy, that's a little bit harder. To get to 92, 94, 96, 98% accurate, it's very difficult. And the reason why that's difficult is there's a very long tail of edge cases. So there's a lot of these hard examples like Nike basketball shoes where you put it under shoes or you put it under sports outdoors. It's hard. These are cases where it's a little bit debatable where you put it in. It's hard for the machine. So to get these edge cases, you need to figure out a system that can really deal well with these cases so that you can get better and better and better. So what do? We use machines and humans together to create a continuously improving system. And to do this, we always talk about scaling machines to big data, but we need to scale humans to big data. And so how can humans make them better? Well, one is you can have humans directly improve the engine by adding more training data and creating rules. So we've talked so far about training data and how that's important, but we haven't really talked about rules. Why create rules? The machine can learn everything. Well, rules create a deterministic solution to solving problems. So let's say the Apple Watch just comes out and you have no training data right now. A human could easily just create a rule that says, if you see Apple Watch and some other information, put this under a smartwatch. So rather than waiting for the training data to be perfect, you can create rules very quickly to make them better. This is a case where the rule can be created by anyone, not a machine learning engineer, but by an analyst or by someone else. So we were talking about a long tail of edge cases. Rules really help for handling these long tail edge cases to make the system better and better. So the types of workers in our system. So generally in most companies you have two types of workers, machine learning engineers and analysts. Machine learning engineers are the ones who have programming experience, algorithm experience, and so on. And the analysts have the domain experience. They're the ones that can say, this category should contain these products, and this category should contain those products. And the two work together to create a system. The problem is, especially at our company, we're about 120 people, we have 2 machine learning engineers and 2 analysts. So with that, how can we deal with a system that categorizes millions of products into 1,300 categories at a 95% accuracy level? It's hard to do with just small people. So the way we can do this is we can add more humans into the system without hiring, without making our company bigger and bigger. What we can do is we can use crowdsourcing and outsourcing to get more human labor into our system. And so the way we can use crowdsourcing, at a high level, crowdsourcing is to get data, opinions, and services from a large online community. So just a quick example, how many of you have seen those pictures of text and you're asked to say what is this text when you're entering a password? Show of hands. Yeah. So the purpose of this is to verify, are you human or not a human? There's actually a second purpose to this system. Google has a very large set of books that they want to digitize, have pictures, and they want to know what the words are in these pictures. So by using this asking humans, they're actually able to digitize the entire book database. So what we use is we use Amazon Mechanics Turk that employs over 500,000 people worldwide. And what's nice is that you can create tasks on demand. So rather than employ people for a set number of hours, we can say, we have a task, we want someone to do the task. We have now 10,000 tasks tomorrow, we want people to do this. And the day after that, we may have 0. The day after that, we may have 1,000,000 tasks. And we can just create tasks on demand for the community to use. So this is an example of a task. And sorry, it's hard to read. But basically, it shows a product description and a merchant and price. And it's asking the user to categorize this product. So what we want to do is we want the user to tell us what is the correct category, so we can understand how well is our system, also as a way to get training data for our system. And if you ask a user to say which 1,300 different categories does this product belong to, that won't work. If you can tell a user which one of 10 categories does this product belong to, that could work. So the way we design this user interface is we ask first of the level 1 categories, of the top categories, what category does this belong to? Is this product sports, or health and beauty, or movies, or music? And then the user clicks. And if the user clicks the first category, we mention this category includes these types of items, and this category does not include those types of items. So then the user says, okay, I made a mistake, let me choose a different category. Or, okay, this is the right category. Then after choosing the level 1 category, choose the level 2 category. So if they choose health and beauty, then they may want to choose either makeup or skincare or something else. And then the second level category. And then after choosing the second level category, then they choose the third level category. So instead of asking them to choose one of 300 different categories, we're asking them to choose 10 categories at a time. In addition, we also are using outsourcing to get more training data, more input to the system. So in this case, we want a particular category, hair color for health and beauty, to be at 95% accuracy. So what we do is sample items we've categorized into this category, and we say what examples are correct and what examples are incorrect. And it's very easy for a human to say, this is correct, this is correct, this is incorrect, this is correct. And then, so that we're able to quickly get more and more training data for our system to have continuously improve and so on. And in this case, it's interesting because through just a text description, it's very hard to understand the product. So what we've done in the interface is you click on something and then see the image of the product to better educate the user on what this product is, so they can be more informed on whether this product belongs to the correct category. But in conclusion, with our system, we've created a continuous monitoring of the quality of our system. It can get better and better and better. It can evolve. And we have a way to create a very large training set without having a lot of human employees in our company. And so we've created a training set of 10 million items and 8,000 rules using this approach. And we're adding more and more daily. Any questions?
Can you stay?
So, in your opinion, what does like the whole, in a very broad stroke, what would be the whole pipeline for you? What step would it involve to be able to reach this ideal situation where we can hand learning engine to people that are not engineers necessarily, and let them just take care of it and improve it?
Yes, we would build an initial engine that machine learning engineers would build, and then this engine would basically label a set of items, and then non-engineers can basically send these items to crowdsourcing or outsourcing workers who give us the correct category or incorrect category. And then we can either choose to automatically add all this training data into the system to get it better, or we can have an analyst look at some of the cases, see, okay, I'm going to add this training data, but these items are often miscategorized. Let me quickly create a rule to make the system better. So now the analyst is working directly with the outsourced and crowdsourced workers to make the system better. And there are some cases where the system cannot get it. The analyst will then talk to the machine learning engineer, but mostly it's the analyst working with the crowdsourced and outsourced workers.
The especially the machine learning part is because machine is learned by itself, right? When you use the human intelligence, it's affecting the machine learning part. I mean to say that when you combine the human with the machine learning, definitely the accuracy will be more better and faster. But that's not the whole about the machine learning. It should be about the machine learning concept, right? It should be learned by itself. That's what the machine learning concept part. Definitely, if human is involved in the process, it will definitely be faster. So, what do you think about this?
Yeah, in the perfect world where you get a machine to really generalize all data and be able to get new training data in an automated fashion. But the problem with all the new products that come out, you don't know the label of these new products. You need humans to do this.
That's what I'm saying, that we need to make the systems like that, our machines learn that, what the human is doing, adding into the system after the new things getting into the future, like a Apple Watch you said. So that the machine need to does that when the product is coming, a new product is coming, and that need to be added to the product. That will be the perfect machine learning. So that the human being adding, obviously, because of the, out of this world, a lot of human beings there. If you involve more people, more accuracy, and the more number of things will be fast. But that's not about the machine learning. I believe in that way, right?
Right. Yeah. So I guess what I'm trying to say is that if you try pure machine learning approach, you may not get what you want. And a lot of people want to build this perfect engine that works by itself autonomously, and that can get, I believe, it can get 80% accuracy. But if you really, really want 85, 98, 99% accuracy, you cannot do this using machine learning. But I think there's an interesting interaction between the two, where a machine can basically say, I'm very confident about the categories of these items. Don't have a human even look at this, because I'm confident. However, these items which I'm not confident about, then bring the humans here. And then when the humans say, okay, this is the correct category for this item, which the machine is not confident on, then the machine can say, okay, what are other items like these products that are unconfident the human has given me? And rather than just taking one item from the human, it can send that to 1,000 using some sort of clustering or deep learning approach. And we're experimenting with that as well. But I guess if we think about it as only just machine learning, I think we're really limiting ourselves because we have access to great sources in this, and especially in this day and age.
True, true. I do understand. Okay, fine. Thanks, Kom.
you. I also have one question related to that point about the rules, which is, let's say that when in the future, the system is better than the rule, become better than the rule. Do you have a way now to actually evaluate that?
Are you saying that the cases where you might create a rule, the rule is actually maybe 90% accurate, and the system might be 95% accurate, or?
Not right now, but for example, for the Apple Watch, it just came out, so the rule makes sense.
Mhm.
But maybe in 1 or 2 years, you will have enough data that the system is better than the rule. And now you have maybe about 18 rules.
Mhm.
So you have a system to actually invalidate rules that are over generalizing, maybe?
That's a very, very good question on rule management. How do you make sure that even though the rules are correct today, maybe in 3 years the rules will no longer be correct? That's a good question, and we haven't really spent as much time thinking about that yet. But one thing we can do is we can look at cases where the machine is very confident that this is the correct category, and the rules agreeing with this case. And if we do enough analysis on these rules that are disagreeing with the machine, and these are all cases where the machine is confident, then maybe the rules should be invalidated. So cases like that we can do.
Thank you.
So thank you very much. So welcome for your time. Thank you for your time. And so that's the end of the session. So let's give Connor a applause. Hi, thank you very much.